While the closed-form expressions for the logit choice probabilities from our earlier video are extremely convenient, this convenience comes at a cost. Consider two alternatives, I and j. Under a logit choice model, the choice probabilities take the following form. And thus, taking the ratio of these, we find that Pni divided by Pnj is equal to e to the power Vni minus Vnj. This says that the probability of choosing alternative I relative to that of choosing alternative j depends only on the representative utilities of I and j. Because it implies that the representative utility Vnk of any other alternative k has no bearing on Alice's choice between I and j, this condition is called the independence of irrelevant alternatives, or IIA for short. IIA arises in logit models because the errors are assumed to be independent. In many real-world examples, however, it is much more plausible to allow dependence between the errors across alternatives. In words, some alternatives are more similar than others, and models that ignore this fact can make nonsensical predictions. Consider an example in which each voter, n, must choose a presidential candidate, j, from the set Trump, Sanders, Warren. Suppose that our model of representative utility takes the form Vnj equals demographics times gamma j plus ideology times beta, where ideology is a vector whose elements measure the ideological similarity between voter n and candidate j on a series of issues, and demographics is a vector of demographic information, for example, age, sex, household income, and so on for each of the voters n. Now, suppose that we restrict our attention to a group of voters who all have the same demographics and ideology. For example, white, centrist, female, Midwesterners between the ages of 45 and 50 with an average household income between 50 and 55,000 US dollars. Since these voters all have the same regressors, V and J doesn't vary over n within the group, so we can just drop the n subscript and write V Trump, V Sanders, and V Warren. First, consider a hypothetical two-way race in which this group of voters must choose between Sanders and Trump. And let's say that 2/3 of them vote for Sanders. Then we have P Sanders divided by P Trump equals 2. Now, let's add Warren back into the mix and consider a choice between all three candidates. Under the independence of irrelevant alternatives, the ratio P Sanders divided by P Trump is unaffected by our addition of Warren to the choice set. The relative choice probabilities of any two alternatives do not depend on the representative utility of some other alternative that may or may not be present. Because Sanders and Warren are ideologically similar, the representative utility of choosing Warren is approximately equal to that of choosing Sanders. Thus, we find that P Warren divided by P Sanders, which under logit choice probabilities is equal to e to the V Warren minus V Sanders, is approximately 1. Because the choice probabilities must sum to 1 across the full choice set, we have the following conditions on the choice probabilities in our three-way race under the IIA assumption. First, P Sanders equals 2 times P Trump. Second, P Sanders is approximately equal to P Warren. And third, P Trump plus P Sanders plus P Warren equals 1. Substituting the first two conditions into the third gives P Trump plus 2P Trump plus 2P Trump equals 1, and thus P Trump equals a fifth. And because the choice probabilities for Warren and Sanders are approximately equal, we have P Warren equals P Sanders equals 2/5. To summarize, in our two-way race, 2/3 of our voters preferred Sanders and a third preferred Trump. Under IIA, this implied that the same voters should break 2/5 for Sanders, 2/5 for Warren, and a fifth for Trump in a three-way race, given that Sanders and Warren are ideologically similar. But based on what we know about the world and these candidates, that conclusion makes absolutely no sense. In reality, we would expect that adding Warren to the race would split the anti-Trump vote, leading to vote shares of around a third Trump, a third Sanders, and a third Warren. To put it another way, IIA implies that a considerable share of people who prefer Trump to Sanders in a two-way race will switch to Warren in a three-way race, a wildly implausible prediction given what we know about these three politicians. The problem with this model is that the logit specification assumes that the errors, epsilon Warren, epsilon Sanders, and epsilon Trump, are independent. In reality, they're not. Voters who have a high value for epsilon Trump likely have very low values for epsilon Sanders and epsilon Warren, and similarly, voters who have a high value for epsilon Sanders also likely have a high value for epsilon Warren. To solve this problem, we would have to go beyond models from the logit family. A popular model that does not impose IIA is the probit model, which is a generalization of probit regression, which we explored in an earlier lecture, to a setting with three or more alternatives. The added flexibility of the probit model does introduce some complications, however. First, choice probabilities are no longer available in closed form, and second, in order to allow correlation between the error terms across alternatives, we actually introduce additional parameters that we have to estimate. While we won't talk further about probit models in this course, they're a very interesting topic that you may have an opportunity to study later in your MPhil course.